This is a quick review to help you fill in the moisture worksheets. Fog is going to form when the air temperature is either equal to or below the dew point. I should add in here below or equal to the dew point. Next, dew is going to form when the ground temperature is equal to or again below the dew point, or equal to the dew point. Frost is going to form when the ground temperature is equal to or lower than the dew point, and if the ground is below freezing temperatures, and freezing temperatures are 32 degrees Fahrenheit or 0 degrees Celsius. Okay, here are some examples. Our dew point in this first example is 50 degrees Fahrenheit. So we're always going to take the air temperature and the ground temperature and compare it back to the dew point. Okay, so our air temperature is 45. So air temperature, which is 45, is less than 50. So what do we get in the air? We would get fog. We have to look at both air temperature and the ground temperature. So let's take a look at the ground temperature. Ground temperature is 55. That's going to be greater than 50. So going back to our rule, you always have to see is either the ground or air less than or equal to the dew point. This is less than or equal to. So the correct answer would be fog. We don't get anything on the ground, but since the air is less than or equal to the dew point, we get fog. Okay, let's take a look at the next one. Next one, our dew point is 28, air temperature is 35, and our ground temperature is 27. Our air temperature, 35 degrees, is greater than 28. Since that's greater than, we do not get fog. Ground temperature, 27, is less than or equal to 28. So in this case, we would get something on the ground. The next thing we have to look at is our temperature greater than or less than freezing point. In this example, it is less than, so we would get frost. Okay, our next example, dew point here is 39, air temperature 40, and the ground temperature 35. What would we get? You can pause to make your prediction. 40 degrees is greater than 39. So we do not get anything in the air. Ground temperature, 35 is less than or equal to 39. So we do get something on the ground. The next thing we have to look at is it above freezing or below freezing? The ground temperature is greater than 32, so it's above freezing, so we get dew. This last example, we have dew point of 79, air temperature of 75, and a ground temperature of 72. Okay, 75 is less than 79. So do we get fog? Yes, we would get fog. Ground temperature, 72, is less than 79. So we would also get something on the ground. What would we get? It is above freezing. So we would get dew and fog. Okay, adiabatic heating and cooling is when air rises, it cools down. As air rises, the air pressure decreases, and that's going to cause the temperature to go down because the air is expanding, and as it's expanding, that uses energy. It uses the heat energy, therefore it cools down. The reverse is true. When air sinks, the air pressure is going to increase, the air molecules get compressed or get squished together, and that's going to cause them to heat up. Some examples of cooling when air is being decompressed would be hairspray or spray paint, or like releasing the air in an air compressor. When you release that pressure, the air molecules expand, that's going to cause them to cool down. You'll feel the container getting colder. Okay, when we are calculating the temperature change going up and down, we can use this formula. High elevation minus the low elevation divided by 100, because it's going to change 1 degree Celsius for every 100 meters we're going up or down, and our units here are in meters. So in this first example, if we go up, my high elevation is 200. My low elevation is 150. And we divide by 100 meters. If we do that math, you should get about 0.5. That means it's going to change by 0.5. Next, if we're going higher, that means we have to subtract a half of a degree because it gets colder. So 15 minus 0.5 would give us 14.5. Okay, we can do the same thing for the next one up. 250 minus 200 divided by 100. You'll see our answer is also 0.5. That means we're going to go down by 0.5, so our answer will be 14. Next, we're going to go from 150 to 100. So 150 minus 100 divided by 100 gives us, again, 0.5. So 15 plus 0.5 is 15.5. We're adding because we are going down, and it gets warmer. Next up, we have 100 minus 50 divided by 100. We'll get 0.5. So 15.5 plus 0.5 gives you 16. Okay, and last, 50 minus 0 over 100 equals 0.5. So 16 plus 0.5 would be 16.5. Okay, I'm going to run through a few examples. This first one, we're looking at calculating the relative humidity. So we need the dry bulb temperature, which is 10 for this first example, and the wet bulb temperature, which is also 10 for this example. So the difference in temperature, we would take 10 minus 10. That would equal 0. Difference means subtract. Okay, so on the chart, notice how the dry bulb temperature we had was 10, but I don't have a difference of 0. What would that be? Remember going back to our psychrometer, if we were at 100% saturation, would we get evaporation? No, we would not get evaporation. Therefore, the wet thermometer would not change. So if our wet bulb and dry bulb were identical, no evaporation would change. That means we're at 100% relative humidity. So our relative humidity would be 100%. Okay, for our next one, our dry bulb temperature is 10. Our wet bulb temperature is 9. So 10 minus 9 equals 1. Now let's go take a look at the chart. Our dry bulb, remember, was 10. Our difference was 1. So follow this over and this down. Our answer is 88. Okay, we'll do one more. Next, our dry bulb temperature is 10. Our wet bulb temperature is 6. So 10 minus 6 equals 4. Go back to that chart. Our dry bulb, remember, if you forget what this is, look at the column. Dry bulb is 10, and our difference was 4. Remember, difference means subtraction, so you can look at the heading if you forget what these represent. Follow the 10 over and the 4 down. Looks like your answer is going to be 55. Okay, next let's take a look at fog, frost, or dew. We're always going to take a look to see what is less than or equal to the dew point. So is the air temperature less than or equal to the dew point? Or is ground less than or equal to the dew point? Remember, we also have to pay attention to freezing. Freezing temperature is 32 degrees Fahrenheit. So for our first example, our dew point is 90, air temperature is 95, and our ground temperature is 91. So 91 is greater than the dew point, so we don't get anything. Next, we will take a look at 84 and 88 and 83. 88 is greater than 84, so we don't get anything in the air. 83 is less than 84, so we get something on the ground. 83 is greater than the freezing point, so that makes it dew. Okay, number 3. 68 is less than 75, so what do we get in the air? We get fog. Next, 40 is greater than 39, so we don't get anything in the air. 32 is less than 39. Therefore, we're going to get something on the ground. 32 is equal to the freezing point, so we would get frost. Last, 44 is less than 45, so what do we get in the air? We get fog. 42 is less than the dew point and is above freezing, so we get dew. So we get two things there. Okay, for the last one, adiabatic cooling, pay attention to the formula over here. So for this first one, we take 2,000 minus 1,480 divided by 520. We're doing 520 and not 100 this time because our units are in feet, not meters. If you do the math, this will equal 1. So that means the temperature is going to change by 1 degree. Since we're going up, 20 degrees minus 1 is 19. Okay, you can pause the video to calculate the rest and then check the answers. Okay, double check your answers. And the last question then would be, where would a cloud form if our dew point is 15 degrees Celsius? So we know the 15 degrees Celsius has got to be between these two numbers. So 15 would be 1 degree more from this elevation. So in order to increase 1 degree, we have to decrease our elevation by 520. 4600 plus 520 equals, so 5,120 feet would be the base of our cloud.